Hello everyone, welcome back. In this video, we are going to see more about the functions and stacking on NumPy arrays. So we'll start with the functions. So let's get started. So first of all, we'll import our NumPy and then we'll create one array. Now we'll see that how we can find uh, minimum element from our array using the minimum function. So we are going to use the np.min function and we'll write our array inside min function, and when we'll execute the code, you will see that the lowest value of the element, that is 3, has been printed. Now we can do it same for the maximum also. So the maximum value present in our array is 61. Now we can find the index at which the minimum element or the maximum element has been present using the arg minimum function. So you will see that our lowest value of the element is present at the first index. Then same we can do it with the maximum also. So our maximum value is present at the third index. Then we can see the square root also of the elements present inside our array by simply using the sqrt function. Then we can see the sign values of the elements present inside our array. So these are the sign values. So we can check the cost values also. Here are the cost values. Now we'll see some more functions for which we have to again import NumPy as NP. So you don't need to import NumPy as NP, but I'm importing it for the better understanding of you guys. And then I'll use the random dot seed function so that the number should not change each time. And then I'm going to make a variable for our array, and then I'll create a random array using the random.randint function, which I have tell you guys in earlier videos. And then I want 9 elements, and I'll reshape into 3 by 3 matrix, and then I'll show you that what my matrix is. So this is my matrix of 9 elements with 3 rows and 3 columns. Now I'm going to perform sum on all the elements present inside the array. So for that I'll use np.sum function, and I'll give my array name, that is matrix, and when I'll execute the code, you'll see the sum that the sum of all the elements present inside our array is 103. Now you can check the minimum value from all of these 9 elements. So for that, what we have to use, you will just simply use the our main function and you will pass matrix. So in this also 3 is the smallest element. Now we can see the maximum also. So the maximum value present inside our array is 20. Okay. Now, now the main part comes here. We can check the minimum and maximum value according to the axis also. So first I'll tell you about the axis, that how axis is used in arrays. So this row, this 13, 20 and 10, this is in a row. and this row is present in axis 1. So the horizontal line always belongs to the axis 1. Okay. Now you can see here this 13, 3, and 8. Now this is a column. This is the first column of our matrix or our array. So this column is a vertical line. So this vertical line always belongs to the axis 0. So now we can perform the minimum and maximum and sum uh, in this way also, that we can check for the particular row. Means row wise we can check that in this row, in means in suppose we I am using, so I'll show you with example. So suppose I'm using the minimum function and I'm giving my array name or my matrix name, and then I can simply write axis equal to, and I want to check it row wise, so I'll give 1 here. So I have told you that 1 is for rows, and when I'll execute the code, you will see that it has given 3 outputs. That first 10, then 3, then 8. So this 10 is taken from here. It is checking in the first row in 13, 20, and 10. So the 10 is the minimum value, so 10 has been printed. Now for the 3. So you will see here in the second row that there is 3, 19, and 9. So it is checking from these 3 elements, and then 3 is the smallest, so 3 has been printed. Now 8. So in the last row you will see that there are 2 8s, so 8 is the smallest value, so 8 has been printed. So we can check it for uh, in column wise also. So for checking in column wise, we can simply just make the axis equal to 0 when we will execute the code. Now this time we'll see it is checking column wise. So in this column, in this 13, 3, and 8, first column, 3 is the smallest, so 3 has been printed. So on in 20, 19, and 8, 8 is the smallest, so 8 has been printed. Now in the last column, 10, 9, 13, 9 is the smallest, so 9 has been printed. So same we can do it for the maximum value also. We can check the maximum value also row wise and column wise. So you can see here, and we have to just change the 1 to 0, and it will check column wise. So you can see here it is checking column wise the maximum values. Now we can perform the sum also row wise and column wise. I'll show you how we can do that. So that is also same, just we have to use the sum function, and inside the sum function we have to make our, if we want to perform row wise, so we'll write 1 here, and you will see that the sum of the matrix which we have given here. So for you guys, I'll print the matrix so that it will be convenient for understanding. Here you will see that our matrix has been printed. So here the sum has been performed row wise. As you can see, 20 plus 10 is 30, and then plus 13 is 43. Then in the second row you can see that 9 plus 9 is uh, 9 plus 9 is 28, and then plus 3 becomes 31. Then again for the last row, that 8 plus 8 is 16, and then plus 13 is 29. So, and we can perform it column wise also. And now it is doing the sum in column wise. You can see that 13 3 is 16, then 8 24, then 20 19 39, and then 8 47, then 10 9 19, and 13 it's 32. So in this way we can perform axis wise. Now there is one cumulative sum. The first I'll show you that how cumulative sum perform. For cumulative sum you have to use cum sum function, and then we have to write our matrix inside it, and when we'll execute the code. Now here we'll see that addition has been performed in a different way. So I'll show you that, I'll tell you that what happens in cumulative sum. So the first element you'll see 13 has been printed. Then what happens? You'll see here that in second element the addition of 13 and 20, 33 has been written. Okay. Now, at the place of 10, means at the place of third element, the addition of the first element, second element, and the third element, that is 43, has been printed. Then with the four element will be the same. The addition of these three, and then with the fourth element, it will become 46, and so on. It will go till the last element. So this is commutation. Now we can perform the cumulative sum also axis wise, and that will be also same. Just we have to write the axis. For row we have to write 1. So you will see that it is performing row wise, and for column wise we have to simply write 0 here, and now it is performing column wise. Now we are going to see shuffle function and unique function. I'll show you how shuffle function works. Shuffle and unique. So before using the shuffle, I will import the NumPy again as np, and then I'll create a array using the random dot randint randint function, and I'll start from 120, and I want to take 10 elements, and then I'll print my array which has been created. So this is my array which has been created. Now I'll do what? I use the random dot shuffle function for shuffling the elements present inside our array. So you will see that this is our element present inside our array. Now this is the base element. Now we are performing shuffle function on our array. So when we perform the shuffle function, you will see that the elements are not changed, but the position of the elements has been changed. Now each time when I'll execute the code, the position will be changed because it is a shuffle function. So it is shuffling all the elements, but it's not changing the elements. So this was all about the shuffle. Now we'll see the unique. Now unique is very important. So let's see at how the unique works. So for unique, I'll create a new array. So I'll create ARR1. So this is my array, and I'll print for you guys. So this is my array. Now I'll perform unique. I'll use the unique function, and then I'll give my array name, and we'll execute the code. Now you'll see that the repeated elements, that is 10, 20, and 30, has not been printed, and the unique elements has only been printed. And we can perform some extra things on unique also, like we can check the size of our unique. So it will print 5, but if you will see the size here, so it is 8. So 3 elements were given 2 times, that's why. And now they are removed using the unique function. So it is good. Now one more thing is present in the unique, that is I'll show you that it takes 3 arguments. That is, first it takes the names of the array, and then it can return the index also. The index actually with the uh, unique elements has been present. So when I'll execute the code, you will see first our unique elements has been printed, and then at which index our unique elements are present, that is present. So you will see first at 0, then 1, then 2, then 3, and after 3 it is present at 7. Now, one more thing can happen to it. It can return the count of the elements also. So for that, we have to use, and then we will make it true. And now you'll see at last that 10, 20, and 30 has been present two times, and 40 and 50 has been present only one time. So this was about the unique. Now we are going to see stacking, that how we can perform stacking on NumPy arrays. So for that, I'll write here stacking. And now I'll show you guys how stacking can be performed. For that, I'll first import NumPy, and then first I'll show you on 1D arrays. So I'll create an array. And this is my first array. Now I have to create one more array. Now this is my second array, and I'll print both of this array. So this is our two arrays. Okay. Now we'll perform stacking in such a way that these two arrays will be combined in one array. So for that, what we'll do, I'll just simply use, first I'll stack it in horizontal way that after 1, 2, 3, 5, 6, 8 will be started in the same line. So I'll show you. For that, we have to use stack function, and inside this we have to give our two arrays. And when we'll execute the code, you will see that in these two arrays has been converted into one array, and then the first array, after the first array, the second array has been, the elements of the second array has been started. You can see here 1, 2, 3, 4, then 5, 6, 7, it has been printed. Now we can perform it in vertical way also. So for that, we have to change here from stack, means from horizontal stack to vertical stack, and then we'll give our two arrays A and B, and you will see now the stacking has been done uh, after the first array, the second element has been performed in one array itself. Okay, now we can perform it in two-dimensional arrays also. So for that, I have to create array. So first I will do, I call the seed function so that the number should be stuck, it will not change. And then I'll create a variable a1, and inside the a1 I'll create random array using the random.random function. And then I'll reshape into 3 by 3 matrix. Then I'll create a b1 variable, and inside it I'll again make a, this time I want from 21 to 40, so I'll write here 41. Again I want, so our 3 by 3 array has been created, and I'll print both of the arrays so that it will be easy for understanding. And when I'll execute the code, you will see two arrays has been printed. One starting from 13, 20, 10, then 399, then 8, 8, 13. Now this is the first one array. Now the second array, it's starting from 31, 22, 37, 35, 23, 29, and 26, 33, 27. Now we will perform stacking. So first we'll see the horizontal stacking. So it is just like same as the 1D array. We have to just give the name, that is A1 and B1. When we'll form it, you will see that first this has been printed, this 13, 20, 10, and after that you will see 31, 22, 37 has been stacked in a horizontal way. Now we can same perform with the vertical also. So you will see that uh, the last elements were 8, 8, 13 here you'll see, and then after that 31, 22, 37, the second array, the elements of the second array has been started. So this was all about the NumPy arrays. Here the NumPy arrays hasn't finished. So thanks for watching the video. We'll meet with a new